Hello, my name is Lance Waffensmith. I'm with Powermation. I'm the business development manager for the Festo product line. Been with the company 15 years, and today we're going to talk about electrical products that Festo has to offer.
And my name is Bryan Johnson. I am a technical sales associate with Powermation and looking to gain as much information from our business development group as possible. So Lance, people know that Festo have very good air cylinders. What is beneficial about Festo's electric actuator?
So Festo's by far and away known as a pneumatic company. They've been around since the early 1900s and have a massive breadth of product in the pneumatic space. But in the last 15 years in particular, they've focused a ton of their investment on the electromechanical side of the business. So, really the use case for electric in general, just speaking between pneumatic and electric, what you really gain with this is the ability to control the position, and control the motion. So you'd use an electric actuator in a spot where you have to go to more than just two positions. That's a good example. Pneumatics, you go end of travel only. It's impossible to accurately position intermediate spots, plus it's open loop, you don't know where it is. Adding sensors gets expensive, and then you can never really position it truly accurate with air because of compressibility. So bringing a servo system and a screw or belt into the mix allows you to control all of those positions. Festo has put a bunch into several different product families. This EGC that we're showcasing here is one of them, and I really like the surface bearing to get high overhung load capacity. This profile rail is head and shoulders best around. But on top of this, they have a new family called their Simplified Motion, which is just teach button. You have little push buttons, you can program it, you don't need field bus. They have a full belt enclosed version called their EGC and EGA family. They've got a heavy duty version of this, which if you could envision this side by side with two parallel rails all in one body, they have that as well. A big breadth of products across the board. They also have the rodded actuators in their ESBF, which is like a traditional rod style air cylinder except with a screw embedded in it. They have that in a couple different versions, a heavy duty and a low cost. So they're just breadth of product, very, very broad. A lot of their products are stocked on the shelf in 100 millimeter increments. So if you're starting at, for example, 100 millimeters and you go up to 1,000, chances are any one of those 100 millimeter increments has got a product on the shelf. Some of the belt driven are stocked in longer versions as well, but they take bigger incremental jumps. You can get them all the way down to the millimeter as well too. So if you have one, you don't want a 200 millimeter, you want a 201. They can custom cut them too. So you could fit into a tight space or make it really fit into your machine precisely or accurately. There are other benefits too, the ability to control the acceleration rate and deceleration rate. If you have a sensitive product you're handling, that alone can be valued and a reason to buy electric over air. Because an air cylinder, what you do is you fill the chamber with air, and it accelerates throughout the entire travel typically, and it doesn't decelerate until the last inch or so, depending on if you have a cushion or a shock. And so you have this really high speed in this short deceleration distance, and you get a huge abrupt shock at the end, and that shock can disrupt a product. It can, just imagine it was a water glass moving. In a glass of water, you come and hit the end of travel, the water would splash all over the place. With electrical, you could control the rate of acceleration and the rate of deceleration. And if your application could benefit from that and nothing more, that's another reason to use electrical. Yeah, there's growing use case. The cost for servo amps and motors and cables have come down considerably in the last 20 years, and it's really just opened these up to a lot of different uses.
So you had mentioned electric actuators. What do we have here today?
So we have Festo's EGC electromechanical product family shown, and I've got both a motor and amplifier to drive these.
Oh, cool. So it looks like we can get all the components from one vendor. What should we talk about first? Where do we start looking at when it comes to sizing and application?
So how do you pick them? How do you size them? So Festo has a really good sizing software tool online that allows you to basically start at the load, and then by entering in a few bits of application information such as speed, force, mass, and then the overall travel, it'll spit out a bill of materials for you so you can have everything you need.
Welcome to Festo's homepage. Right now we're going to look at the online electric motion sizing software. So let's get to the tools right away. Going underneath products and digital engineering tools, we will scroll down to the second section, electric systems. Here we have two options, electric motion sizing and handling guide online. Handling guide online is meant for more complex systems with more moving parts, but today we're just going to size out a small, simple one-axis solution. Let's select what type of movement we have. Choosing linear, we can see we have more options. 2-position, cantilever axis, multiple position, or a pneumatic-like cylinder that is electric. Let's go with the multiple position. Here we have some more arguments. Up top, we have communications, actuator type, and how it will be mounted. Down below, we have a position table, so let's put in a few things here. Starting out with our first position, adding a small payload. The rest of these are optional arguments, but let's say we have a known cycle time that we're trying to achieve, so we can put that time over on the right-hand side. Adding our second position, same payload, we know this cycle time, so we'll put that in as well. Continuing to the next step, Festo's software will recommend us solutions that will work for our parameters. So right away at the top, we can see solution number 1 is the most economic solution. This is what Festo recommends as the best bang for your buck. However, there are other options we can see here, along with more arguments we can filter on this side. Let's stick with the communications, 24-volt logic, 120-volt supply. We will not be using 480. Some other things we can filter out is that we know we want a servo motor instead of a stepper motor for better positioning of our system. And we can even choose if we know what family of actuator we like. I'm going to narrow down this search to the products that we have available to us and just show you what the software returns. Back at the top, we can take a look at what we have here and looking for this solution right here. These are the products we have available to us. So let's take a look here. Some cool things that the software does is it tells you how worked the drive and the motor are so that you can see if you're creeping into some dangerous territories. Some other things that this software offers are some cool specifications on what the profile might look like. And as you drag your mouse across, you can get some more detailed information, along with characteristics of the motor and even a bill of materials to tell us everything that we have. With one click, we can add this to our basket. And even over here, this little download icon has some cool things. So we can download a fact sheet. This pops up down here. And again, this is everything we just saw in the previous slides. If you want to run this past your team, you can get a quick snapshot of what your solution will look like. Other downloads it offers is a commissioning file for our Festo's automation suite, which we will take a look at later on. This commissioning file is super cool. It really makes the setup a lot easier and could not be smoother. So now that we have our system all spec'd out, let's head back to Lance and learn a bit more about these actuators.
Now, what is different between? I see you have two different rails here. What are the difference between these two?
So the EGC family, and matter of fact, all Festo stuff, whether it's this, because we haven't really got into the other products they offer. They have a very broad range. They all have an accompanied passive guide axis. So in the case of this actuator, this has a ball screw. So they're offered in both ball screw and timing belt drive. And then another thing is you can use these passive guide axes, which are just a bearing support, just an added support for, if you have a large cantilever load that was hanging over, you could add this to improve the overall life of the system.
Nice. So this makes the system overall a bit stronger, but I've heard these rails are quite strong to begin with. How did the engineering come from these?
Well, as far as the design of, taking a step back, the reason I really focused on this product itself is I love the ground up design. So if you were to strip this away and show the internals, the structure of this actuator was intended solely for electrical use. It doesn't have a pneumatic counterpart, or even the belt drive is unique compared to the screw drive. And
So now that we know it can carry big loads and doesn't have too much of an issue doing it, how do we move it back and forth? So you mentioned that there is a ball screw variant and a belt variant. Could you help me out on why someone might select each option?
Sure. So screws, a common use for screw is if you really have fine positioning, extremely smooth motion, or heavy loads. Those are, generically speaking, some good use for screw. If you're moving extremely fast, horizontally mounted, or need to go in a very, very long travel length, that's when a belt comes into play. So generically speaking, belts are better for high speed, long lengths. Screws are better for higher thrusts or heavier loads.
So now that we've covered the drive and difference between a ball screw and a belt, let's talk about what is going to be moving that. Here we have the motor. What's unique about this motor?
So with these electromechanical actuators, they have a finite travel distance, and most of the time people want to position them very precisely at the positions for their application. So in order to do that, it's best to use a brushless servo motor with a feedback device. In this case, Festo makes not only that motor, but they also make an accompanying drive. And this particular motor happens to be made with some of the latest technology. It has a single cable design, multi-turn feedback, so you get true absolute feedback, which is nice because if you lose power anywhere along this axis, after it repowers, it knows exactly where it is. So it wakes up and knows its position.
I also see it's not directly mounted to the rail. We have a coupling mechanism.
Yep. Motion grade. So this is a just motor mounting adapter with a motion grade coupling in there, really intended to handle the rapid reversals from a servo. So everything's truly motion rated. They're also this. You don't necessarily have to use a Festo motor either. Festo makes adapters for all the big servo motor manufacturers, whether it's someone like Rockwell or Siemens, the gearbox makers out there, Apex Dynamics and others. Their adapter assortment is intended to accompany all the big players. Well, really broad.
And one thing you had mentioned is this motor has a feedback with it as well. Is there any other sensors that we could put on this for better positioning?
You could, yeah. So the family here, it's going to be hard, might be hard to show from the camera view, But the actuator is made with this recessed pocket to accept position sensors. So you could have end of travel position, a homing sensor, sensors on both ends. You can also buy it with an embedded absolute positioning device. So if that's often used for a safety device mainly. That's the main intent there, is if you were to ever somehow something catastrophic occurred and you lost this motor, you could have a secondary position device that could indicate motion and bring a brake on.
So as we got into safety a bit there, what safety functions does this controller offer?
So the amplifier here has a handful of new safety features. It can do safe stop category 0 and 1, which is decelerate and hold, or just open and coast. It also has safe torque off built in. If you're using field bus, like Profinet for example, it incorporates the Profi Safe protocol for safety also. So it's got a lot of good modern machine builder safety features.
Now that we've covered some technical aspects about this product, let's take a closer look at it in action. We have two different motion profiles set up that we're going to show you. One of them is smooth motion, that is meant for delicate applications or something with high inertial loads. And the second one is a high cycle rate motion profile that allows production facilities to achieve a very high throughput. So let's begin.
A lot of manufacturers in this space are starting to move more and more to a one software platform, and Festo's taken that approach as well. A few years back, they developed a software suite called Automation Suite, and within Automation Suite, you commission an amplifier like this along with a whole host of other Festo products. You can program a controller that would communicate to that using their programming software. You do firmware updates with it. You can firmware update not only one amplifier, but a sequence number of amplifiers that exist in your project can all sequentially be firmware updated at once. So they've put a lot into one development package that can do all of those different functions in one.
Great. Now how about we go take a look at commissioning this drive within the software.
Okay, welcome back. Now let's take another look at some other Festo software. Here we have Automation Suite. This is perfect for commissioning our electric systems. And this is the home screen. We have just launched the application and we are offered a few options. We can create a new project or we can import some data. Let's go to import data and see if we can use the commissioning file that we just downloaded from the electric sizing software. So as we go to import electric motion sizing, see if we can find this file. There it is. We'll open it. And that's about it. I'll double click on the drive. And as this software initializes everything, we'll just take a moment to wait. Okay, so after successfully importing the commissioning file, we can see all of our products up on the screen at once with all of their data along with it. Other things about the software you might notice is the control tab if you want to do some manual jogging of the axis, or a diagnose tab if you are receiving errors. Why don't we go over to start first, setup, and here we can see some of the same information we had on the previous page, along with some device settings for the drive so that we can get our communications correct. Application data is quite cool because it has all of the components preloaded, so the software knows what's going to be moving and you don't have to fill in any of these values manually if you were to go to more than one vendor for your motion needs. This is a great part about using Festo because it's all from one source. It all works seamlessly. We have some other menus in here, hardware switches, honing method, some preset software elements that we can input for our system. Going back to the main page, we can take a look at some other menu items over here on the left. And down here, we can find a record table if you want to quickly set up a demo or get this system up and running without fully programming your motion controller. So we can do a new record set and we can do like a motion task. We can set a position and where we want the position to be. Again, we'll just do something simple. We have position 1, and let's say we can get to a second position. And now we have 2 positions. To get this nice and looped, we can link position 2 to position 1. So after we reach position 1, let's go to position 2. And then maybe after we hit position 2, let's go back to position 1. Now this just kind of creates a loop that will go from 10 millimeters to 650 millimeters. This is good to see, how well your motion system is working for your application. That's how you'd set up your record table. And if you go over to control, you can go to your record table and you can play it from the start and watch it move. So that is a quick look at Festo's automation suite and all the cool things it offers, such as the drive configuration, where it gives all of your information right here. Easy to import the file from the motion sizing software. And again, this application data tab over here is pretty sweet, so you don't have to do any of the tuning values yourself. Thanks for joining me in this part of the software demo, and let's head back to the stage.
So that was a quick look at commissioning a Festo servo drive in Festo's Automation Suite platform.
Thanks for watching the PowerMation YouTube channel. Feel free to like and subscribe. And in the meantime, if you have any questions, reach out to me via the PowerMation website or give us a call. Thanks again.